I'm still going to use the Streaming Students project from the previous video, but I'll start by creating a new class called MainCollect. This way, I can keep the collect code in a single place. I'll include a main method in this class. I'll copy the code to create the two courses from the main class's main method, so lines 13 and 14. Instead of setting up an array and populating it with the randomly generated students, this time I'll stream students with the generate method into a list using toList. At this point, I really don't want to modify my first collection of students once I have them, so getting back an unmodifiable list is fine. I'll start with a list of students called students. I'll call stream.generate and pass it almost the same lambda expression I used in the setAll method for the array in the main class's main method. Here, its type is supplier, which means it takes no arguments. It starts with empty parentheses and then returns random students from that static method onStudent. I'll limit this to 1000 students, and I'll call toList, which gives me a list of students in the order they were created. Next, I want to get a set of my Australian students. I'll set up a local variable, a set, with a type argument of student and call it Australian students. I'll start by getting a stream from my students list. I'll filter using getCountryCode on student and testing for AU. Here I'll collect to a set using collectors.toSet. I'll print out the number of students in my set. This method is a lot like collectors.toList, but it returns a hash set. If I run this code now, I will get a different number of Aussie students each time, but that number should be about 1/7 of the total students. Next, I want another set called under 30 for students who enrolled when they were under 30. I'll copy the statements above and paste a copy just below. I'll change the variable name to under 30. I'll change the condition I'm filtering on to check if the age enrolled is less than 30. Lastly, I want the text that gets printed out to print the under 30 students and use under 30 dot size. Okay, so this is just a different query about our student population. Running this several times, I'll get a different number of under 30s. Now let's say I want to understand how many of the under 30s are also Australian. If your population is very large and your sets are much smaller, there's an argument for using some set math rather than processing another stream pipeline. Let's walk through an example of this first. I'll create a new set and call it Young Aussies 1. I want this to be a tree set and I want it ordered by student ID, so I can do this by passing a comparator into the constructor of treeset. I'll add all my Australian students. I'll use retain all on students who are also under 30. Remember, this is really an intersect of the two sets, returning only the students who are in both sets. I'll print each student's ID out on a single line separated by spaces, and finish with a new line. If I run this code, I should get a list of student IDs. These are the students who are both from Australia and were under 30 when they enrolled. Now let's just do the same thing, but use a stream pipeline. I will copy the under 30 stream pipeline and paste it at the end of this method. I'll change the variable name to Young Aussies 2. I'll copy the filter from Australian students on line 23 and paste that as a second filter in my new stream pipeline. I'll also copy the two output statements from lines 36 and 37, pasting a copy at the end of this method. I'll change Young Aussies 1 to Young Aussies 2. I'll run that now. The good news is I get the same set of IDs, but the bad news is that the last set's not ordered. Can I just add sorted to the pipeline? Let me try that. I'll insert that before the collect terminal operation. Notice that IntelliJ has it greyed out. If I hover over that, I get the message that sorted is redundant because toSet doesn't depend on the sort order. The pipeline knows the set isn't ordered, so it would be wasted effort to sort it here. But let's say I really do want it sorted. This means I want a tree set and not a hash set. Is there a collectors helper method for that? Well, there isn't, at least not like the collectors.toSet method. This means that I could either pass this hash set to a tree set constructor later. My other option is to use the overloaded version of collect. Before I do that, I want to first go up to this toSet method call, and I'll control click on it. This opens a window that shows me the code it's using. You don't have to understand all of this to understand a few important points, namely that there are 4 parameters, 3 are either method references or lambda expressions. These are the 3 we'd use if we were to do something similar. In truth, I do want to do something very similar using the alternate collect method, passing expressions that mirror these. The first method reference in this code instantiates the new hash set. This is the supplier. The second method reference adds 1 element at a time to the hash set. This is the accumulator. The third is a lambda expression and a little more complex. Mainly what I want you to see is that it's calling add all on the set, so it's adding one collection to another collection. That's the combiner. That's enough information to get us started, so let's get back to the code. I'm going to remove collectors.toSet as an argument in the collect terminal operation. I'll replace it with 3 arguments this time. First, the supplier. You saw that the code we just looked at had hashset : new for its supplier, so you'd imagine I could put treeset : new here, which I'll do. The second parameter is the accumulator, and that would be the same as when I'd use the hash set, so I'll add that as a method reference too. The combiner might be a little confusing because I haven't covered parallel streams or splitting up your streams to process them more efficiently. In this case, they'd need to be put back together, and that's what this method would be needed for. It joins the results of multiple streams' accumulated outputs into a single collection, and this would be done using an add all method. In our case, it's not likely to be used, but it's still required. And that's it, we've set up our first collect method with a supplier, accumulator, and combiner. Notice that the sorted method isn't grayed out anymore, but it isn't needed either, so I'll remove it. The tree set is ordered as elements are added. I'll run this. But this doesn't work, I get an exception. That's because student doesn't implement comparable. This is the same reason I had to set up the tree set for the Young Aussies one variable with my own comparator. I want to do that here, but how do I do it? Well, I can't use a method reference for the supplier to do it. I need to change that first argument to use a lambda expression. I'll start with the empty parentheses, and after the arrow token, I'll have new tree set, and in the constructor parentheses, I'll pass a comparator. I'll build this like I did before when I created the tree set for the Young Aussies 1 set. If I run my code now, it works and I get the same results from both sets. The collect method has 2 overloaded versions. I show them here again without showing the generic type parameters. The first can be used by passing it the result of any of the many factory methods on the collectors class. I showed you asList and asSet as 2 examples of static methods on that class. The second is more complex, but gives you ultimate flexibility, as you saw with the tree set example I just showed you. You could also create your own collector type by writing a class that implements collector, overriding those abstract methods with custom functionality. Before I end this video, I want to cover the reduce terminal operation, so let's get back to the code. The reduce method is different from collect because you're not accumulating elements into a container. Instead, you're accumulating elements into a single type. Let me show you an example of this. I'll set up a variable called country list and start a stream pipeline on students. I'll map to the country using getCountryCode. I only want distinct countries. I'll sort. And now I'll seed this with an empty string, returning a concatenated string with the currently accumulated one plus the new value or country. And I'll print that out. Running this code, I'll get my country codes printed out as a single concatenated string. You can imagine this would be useful if you didn't know the distinct values in some fields, because this method lets you get them all in a single string. Okay, so that covers the introduction to the collect and reduce terminal operations. These methods can be used to do almost any kind of transformation you can think of. I'll be covering more complex features as we move forward. For now though, I'll end this video and give you a small challenge in the next one.